So I'm Tuff, head of platform at Blockchain. Today I'm going to be talking about how we brought retail trading to 34 million cryptocurrency wallets globally. So first off, who is blockchain? Now you may have heard of the term branded around. So we are blockchain.com, a technology company and actually the world's leading digital asset platform. So we started our life as a blockchain explorer, specifically for Bitcoin. And then we've evolved and grown many products over the last 5 years. One of our most popular is our cryptocurrency wallet. We've also launched a number of our consumer products, including the ability to trade cryptocurrency. And we have data products, market research, APIs for live streaming data on blockchain analytics. And we've also launched a number of institutional products. I'll go into more details on some of these later on in the presentation. So how do we compare it to the market? And who is our kind of main competition? So you may have heard of a company called Coinbase. So the difference between us and them is that they focus more on the custodial offering, which means they're taking custody of your digital assets and funds. And in return, you can use their platform and services. For us, we've taken a non-custodial first approach, which means we're empowering users to take full control of their private keys and digital assets. At no point do we take ownership of those and compromise your security or privacy. So that means you are no longer reliant on a third party, a centralized entity, or risk of any one person losing or being compromised with your digital assets and funds. So our key aim really is to empower users and educate them to allow them to take control in a secure and simple manner. And our tagline here, you can see, is be your own bank. We want every user to consider becoming their own bank. And that is surprisingly easier said than done. So we have 3 main clients. We have an iOS, Android, and web platform. Here are some screenshots of our iOS application. And I've highlighted some of the key features and functionality that our mobile applications offer. So as I mentioned, these are all non-custodial. So they're fat clients or wallets. So a lot of the heavy lifting is done actually browser side or on the client themselves. Our backend is purely to store some metadata and to interact with the underlying blockchain network. So here you can see you have an overview of your cryptocurrency assets, your current balances, the live market price. You have the ability to buy and sell cryptocurrencies with fiat on and off ramps. You can exchange your cryptocurrencies for any other asset that you may be interested in and get live pricing. And I'm going to go into a bit more detail on the architecture behind that. And then finally, common use case, you can send and receive cryptocurrency funds very easily and very securely from right within our mobile apps or from within the web wallet. And as I say, you never have to give up custody of your assets to do this. So where are we today? So right now we have 34 million wallets globally and growing. We're doing over 10 million new wallets a year currently. That equates to around 100,000 transactions per day that are being processed through our software platform. In total to date, that's $200 billion worth of transactive volume has flown through our software application and platform. And I think for me, most excitingly, that actually accounts for 25% of the global network traffic on the Bitcoin network. And then finally, we currently have a user base that spans over 140 different countries worldwide. So first up, our Explorer. So here on the slide, you can see we have this common interface into many different underlying blockchains, notably Bitcoin, Ethereum, and Bitcoin Cash right now. There's 3 main sections on the Explorer. The first is the input to look up your address, your transaction hash, or a block. Second middle section is key stats and blockchain metrics, such as the current difficulty or the mempool size. And then finally, we have a real-time view of incoming transactions and blocks that are being mined. So I want to delve now a bit deeper into what does it take to run a a web platform like that, and how do we achieve, in real time, the stream of data from these underlying chains? And more importantly, how do we do that at scale? If we're getting around 2,500 requests per minute consistently, and that kind of peaks even higher with kind of significant price movements. So how does it work? So this is obviously a simplified overview, but as I mentioned, we have three main consumers of our platform. So that is our mobile wallets on iOS, Android, and the web. We have our Explorer, which I just showed on the previous slide. And we also have a number of public APIs where any individual or company can build on top of our platform. And they can actually use it for creating transactions, sending, receiving, and also just consuming and ingesting the blockchain data directly without having to do the kind of hard work of integrating with the underlying chains. And within the middle, we have this data ingestion service platform. So internal to us, we've built out a number of services that are responsible for interacting with the underlying chains, such as Bitcoin, Ethereum, Cash, Stellar, etc. So we create a wrapper around these that interacts with the low-level APIs that they provide. We actually spin up and run all of our own nodes in GCP. And then we have a number of other services and components that then ingest all of the real-time blocks and transactions, extract the key insights and metrics, do any kind of transformations we need, and then persist that within a relational database. We then serve that back up to our clients on demand at scale. Between that, we do have caching layers and a number of other technologies to mitigate issues at scale, which I will go into a bit further. But a key thing here is that a lot of the complexity of pulling out a very simple attribute like your balance is abstracted away from the user, both in terms of the UI and UX experience you get from within our clients, but also for our unified API. So you no longer have to spin up your own node, become a part of the public network, understand their APIs, which are often pretty low level, interpret the data, which again is usually at a lower level of abstraction. Now you just have one API to interact with to seamlessly send, receive, and process all of the blockchain data. So how do we evolve? So I wanted to set the scene on our scale of our infrastructure to support our platform, both the Explorer cryptocurrency wallet and a number of other products. So you can see here we're running over 2,500 cores currently in GCP, and around 9 terabytes of virtual memory. You can see the graph. The wallet accounts that have been created over the last 5-6 years have grown tremendously, especially since 2017, when the news kind of hit mainstream and cryptocurrencies were suddenly being discussed by every single person on the street. I think astonishingly, and something that we realized wasn't going to scale, was that a third of our infrastructure was dedicated to our in-memory NDB cluster. And this was running our Explorer and our cryptocurrency wallets. So the backbone for all of those. And it was done ourselves by our engineering team. So we're using most predominantly compute engine and running all this stuff ourselves at scale. As many of you will know, that doing that beyond a point becomes extremely costly, both from a monetary perspective, but also from the operational overhead of maintaining it, upgrading it, and dealing with the fallout of failures. So we ran over 24 nodes to bake in our own redundancy and make sure we are fault tolerant. And to do any kind of scaling, we cannot scale linearly or on demand. We had to actually spin up a whole new cluster alongside our production cluster, restore each of the underlying chains, so for example, the Bitcoin blockchain, from the beginning. And that would take around 1 week, all being well. And then once it had caught up, we could then flick the switch and move our applications over to the new production cluster. Because of the pain involved and the time it took to do this, we would just, last year, just doubled our infrastructure overnight, just to support our exponential growth. Now, I just quickly realized that this is not sustainable. So at the beginning of last year, we started to consider what are the other options we have here, and how can we reduce the operational overhead of running this at scale, and ensuring that our infrastructure was going to support us on our mission to grow and redefine kind of financial infrastructure of the world. So in comes Clyde Spanner. So we looked at a number of different products, and we decided to try a prototype and POC on Clyde Spanner. Now, the impressive thing here is that within a few minutes, we were able to spin up a production cluster and have strong consistency, globally distributed, at scale. And all of that for a marginal increase in cost as to running just compute engine and managing this infrastructure ourselves. So early signs were promising. We then switched and re-architected our application, started to re-implement our schema, and decided to actually go all in on Clyde Spanner, initially for our Bitcoin blockchain ingestion process. One of the key things we did early on, which really benefited the engineering team, is that we connected with the Clyde Spanner team directly. So we had a few conversations with technical PM Deepti and a number of engineers in her team, and they really helped us through the initial hurdles of getting set up on a brand new technology and really understanding the nuances of where it was going to work and some of the constraints of running at scale. We had to make some design decisions early on that, without that help, would have been costly to change later. I think one of the key features that really benefited us during this iterative development process was the fact that we can now do a full import and export in record time. So we could back up our whole database in just 30 minutes. As I mentioned before, it took 1 week to restore that. We can now do it in a batch job overnight in just 8.5 hours. So what this meant is that we could rapidly develop our application and services, do a lot of testing and playing around with different schemas and architectures. And also, once we were happy, we could then promote that through each of the environments: dev, staging, pre-prod, and then finally to production. And that was simple, quick, and efficient. You'll notice here as well that we have, this is our production comparison. So we have under half of the original nodes that we needed before, now just 10 nodes. And all the reasons for that is because you're getting redundancy, high availability, strong consistency, and global replication as part of the package. And then finally, we could scale on demand. So at a touch of a button, we could double our infrastructure. We could also set predefined thresholds and have that elastic on demand. The final thing is we actually leveraged table interleaving, which meant that we could take some of the complex queries we were running against our NDB cluster previously and reduce the time it took to run those from 30 seconds down to around 15 milliseconds. So the whole migration was hugely impactful for us and our products. And now we've been running this for around 6 months in production. Overall, on average, I just did a comparison before I came, and we are saving around 30% month on month in terms of the dollar amount, which is pretty impressive when usually some of the hesitation about moving to software as a service and some of these cloud services is the expense is going to just creep up as you grow. But actually, we've seen the opposite. We've not only reduced the operational overhead of managing this at scale, we've also made our CFO very happy. So how else is this data set used, and what other products do we offer? So as I mentioned earlier, we built out a crypto-to-crypto exchange product. Again, leveraging a number of cloud services and operating at a significant scale. So this allows you to exchange across-chain transactions and get live exchange-like pricing right from within your non-custodial wallet. So again, you never have to send your funds anywhere and give up the custody of your assets to any one individual company or entity. Your private keys remain with you on your device or in your browser. Here's a quick demo of the product. So this is on one of our mobile applications. You'd simply just type in the amount you wish to sell or buy. You'd get live pricing right from within the app in real time, and you can exchange between multiple pairs that we offer. You finally get a summary screen, confirm, and that's it. So what's really going on, and what are some of the complexities with building out this, hopefully you'd agree, smooth user experience? So the key challenges. Security. So for us, blockchain as a company, security is our #1 priority in everything we do. You may have heard of some of the horror stories from cryptocurrency companies in the space that have been hacked, compromised, or lost their users' funds. We don't want to be in the next headline, so everything we do goes through a very rigorous process. Volatility. So within the marketplace, if any of you follow the cryptocurrency pricing, you'll see that it's extremely volatile, maybe swinging by 20 to 50% in a day. So how do you create a smooth user experience when the price is jumping around all over the place? The third challenge, public network. I think this is an important one. Now we are relying on infrastructure that is outside of our control. We're no longer just relying on our private network within GCP and the services that we've built. We now have to broadcast and send transactions over a network and many nodes globally distributed. So what are some of the constraints when you do that? And then finally, high availability. I think it's kind of a given for any technology company now, but it's worth noting, how do you achieve that at scale? And again, what are some of the design decisions and architectural decisions you have to make early on to ensure you achieve that? So the interesting part, how does it work? So I want to give you a little bit of information on what's under the hood and how does the architecture actually look. This is a slight simplification, but it gives you a very good idea by some of the core components and interactions between those. We do leverage a number of cloud services to achieve this, and I'll mention where they fit into the stack. But as you saw on the previous slide, first of all, you start with the client. So Android, iOS, or web. You then have a secure connection to our backend via our client gateways. And the user will connect to the swap product, initiate a secure WebSocket connection, and this will start streaming live prices to their device. The user types in the volume they wish to sell or buy, and we then adjust our pricing based upon that input. We have a liquidity and execution engine, which is the driving force of all of our trading activity. And that has connections to many different exchanges, market makers, and brokers, and also our internal inventory. So that's managing risk, portfolio management, and pricing. Internally as well, we've also built our own custodial solution. This is a multi-tiered custody solution of which the hot wallet is at the top of the stack. So this is the only part of it or layer that is programmatically accessible and secured within our internal network. All others are air-gapped and have a number of other security policies in place. So once the user is happy with the price, they hit exchange. What happens next? So our client gateways will go off to our liquidity engine and say, hey, I want to execute a trade to sell half a Bitcoin. Liquidity engine will then lock in the price and send back how much of the countercurrency they wish to receive. So let's, for example, say, I want to sell Bitcoin for Ethereum. In parallel, we initiate a request to our hot wallet, which is the gateway to all of our nodes. So these are the blockchain nodes: Stellar, XLM, Bitcoin, Bitcoin Cash, Ethereum, etc. We'll then generate a deposit address, which the hot wallet service will persist and start listening on for any incoming deposits. We then combine these transactions, send it back to the client, and the client then returns to the user the final amount they need to send us to receive their Ethereum. And then client side, the browser and or the mobile client will construct that transaction and sign it using their private keys, and then broadcast that out to the underlying respective network. None of that touches our backend. That's all done client side, as mentioned earlier. Now it will be sent and broadcast across the public network, and we wait patiently for that to hit a network broadcast event and a confirmation event. And the hot wallet is responsible for that. Once those have been received off the public network, we then use Kafka as our main message bus. So we have an event-driven architecture. So this sends an event over Kafka. One of the consumers is our client gateways. That picks it up and then processes that. We then compare that against our state machine, transition through the life cycle, say, hey, deposit received. We now need to pend a withdrawal. We update the user and say, hey, we've received your deposit. We're now going to initiate the withdrawal request for you. We then make a call back to the hot wallet and send the amount we wish to withdraw and the deposit address that was sent from the client originally. And again, that's then broadcast out on the public network. The client will then receive the funds in due course, usually within half an hour, and we notify them via push, via email, via SMS. I think one of the interesting cases that happened recently is that these public blockchains can have many different use cases apart from just transferring a store of value. And one of them is actually being leveraged for marketing. So what that means is actually every time anyone sends a transaction on the Bitcoin Cash network, and someone is listening because you have this public ledger, they're listening for this address. And any new address that appears, they then send you a little marketing message. And what does that mean materially? It means that actually we as a company on our deposit address receive more funds than the user actually sent. And also the user receives slightly more funds than we sent them. They also receive 2 transactions instead of 1. So this was kind of a very interesting use case where we had to be flexible and defensively programmed for this in the future. And finally, the node gateways at the bottom are really the data ingestion service platform that I mentioned previously, and our way of wrapping each of the underlying blockchain nodes. So one of the other interesting things that we've managed to do is build out a hardware device which is a secure way of storing your cryptocurrency assets offline. This has full interoperability with all of our platform and software. So you can use our swap product, as I showed you before, and your keys never have to leave the physical device. So this is hugely beneficial to a lot of users who are security conscious and maybe don't trust the terminal or workstation they're using. And we've managed to achieve this leveraging our existing interface and software. Some of the key benefits of using Google. So I mentioned a few of these already, but I wanted to kind of summarize and highlight these before finishing up. So one of the things that GSP has really allowed us to do is scale up our infrastructure on demand. When you're dealing with tens of millions of wallet accounts globally, it's important that you're not constrained by the infrastructure that you are using. We've had many cases when the price has moved significantly, and suddenly the number of users that we're onboarding every day has gone up 5 or 10 times. And we've had to actually scale up our infrastructure significantly during those periods. I mean, in the peaks of the last few months, we've seen over 100,000 new wallets being created every single day, and up to kind of 1 million in a given week. So there's significant strains on our infrastructure that we have to account for. And one of the things we do, as I mentioned previously, is adding a number of caching layers. Take a lot of advantage of CDNs and do a lot of load balancing across many instances. For the most part, all of our infrastructure is stateless, so it means we can horizontally scale it on demand. Also, on the previous architecture, we're leveraging cloud services where possible. It means that our team can focus and hone in on some of our very specific domain complexities and challenges and not worry about running our infrastructure at scale and solving the problems that Google have been doing for many years. So they spend less time, energy, and effort on managing our infrastructure and more time focusing on building what we believe to be the future of finance. As I mentioned, we have high availability, so we're leveraging Cloud SQL, we're leveraging Spanner. We use a number of other services quite broadly across our architecture. As you can imagine, we have a lot of microservices within our architecture. So being able to just quickly spin up a highly available, redundant, and scalable database at a click of a button is very powerful. And we're using both Postgres and MySQL engines for that. And the third point is that it's engineering friendly. I think all of our engineers, whatever their skill set or focus, enjoy the GCP experience. Whether that's because of using the CLI and programmatically writing scripts around that, or using the interface itself to dive into problems and debugging issues. And finally, the fourth one, which I mentioned earlier, of our Spanner story, is the technical support. So I think a lot of people don't realize the amount of support that Google offer you as a company. We can tap into a wealth of knowledge and domain expertise through our account managers and customer engineers. And we do that pretty regularly. We've had many conversations comparing Google products to other open source technologies and the pros and cons of using them. So another story that happened last year, we were just trying to decide on the correct message bus architecture for this trading product and for many others. One of our key requirements was sequencing. So we then spoke with the technical PMs from the PubSub team and had a real candid conversation about what were the pros and cons of using PubSub above Kafka. And the net result of that conversation was that we used Kafka, and that was their recommendation. I think that's quite refreshing when you can actually connect with the engineers at a cloud company, and they recommend a product which they do not support or sell themselves.